Okay, today we're going to look at parallel lines. Parallel lines are lines that do not intersect. So they will go on forever in both directions out to infinity, never actually touching each other. So if you look at these two parallel lines over here, you can see that they are spaced apart from each other, but really don't look like by the angles at which they are in the grid that they would ever actually intersect. Let's look at their slopes and see if we notice anything special about their slopes. So firstly, let's call this line line 1 and this one line 2, just so you know and I know which lines we're referring to. So for line 1, we can certainly take the 2 points and subtract the y's and subtract the x's and mathematically calculate the slopes, or we can also count out the rise over the run. So for line 1, we are rising 4 and running 2, up 4 over 2, which simplifies to a slope of 2. For line 2, we are rising, let's see, 1, 2, 3, 4, 1, 2, and running 2. Hopefully, you notice that these two parallel lines have the same slopes. And that's actually a property that you'll find with every pair of parallel lines, is that they will always have the exact same slopes. So what we'll be able to do is, if we know that parallel lines have the same slopes, we can write equations for parallel lines, even if we're not given a whole lot of information. So let's take a look at writing the equations of the lines. So we know that both of their slopes were slopes of 2. Here's line 1 and line 2. Now let's write the equations of the lines. So for line 1, we've got a y-intercept of 2. So we can use y equals mx plus b, since we have a slope and we have a y-intercept, giving us y equals 2x plus 2, our y-intercept. Line 2 has a y-intercept of -1. So its equation is y equals 2x minus 1. Again, we can see the slopes the same in these equations. However, I hope you notice that the two lines equations have different y-intercepts. Parallel lines should always have different y-intercepts but the same slopes. They're different y-intercepts because they're at different places on your grid. The same slopes mean they're increasing at that same rate throughout the whole grid and that whole line. That same slope means that they're not going to ever intersect because they are at the same steepness. So when you see two equations of lines that share the same slope but different y-intercept, those lines are parallel. So to practice this, we can write the equation of different lines given information. So let's look at this one. Write an equation in slope-intercept form of the line that passes through 4, 0 and is parallel to the graph of 4x minus 3y equals 2. So we want a line, if I did a quick little sketch over here, going through the point 4, 0, and we want it to be parallel to whatever this line's equation is, or that equation's line is. So what we should do is first let's start out by transforming this equation that we're given into a form that can help us. So for example, let's take 4x minus 3y equal 2, and let's try to find the slope of it. Since they're parallel lines, we want the same slopes. So we're going to take 4x minus 3y equals 2, and we are going to transform it to get it into y equals mx plus b form, meaning that our y is isolated and the number in the place of m will then tell us our slope. Okay, so I'm going to bring this 4x over to the right side, so I'm going to have to subtract it, which will leave me with a -3y equals negative 4x plus 2. I put the negative 4x part first because I knew that the thing with the m is with the x is eventually going to be our slope, or that m. So I just deliberately put it first on that side. Now that we've got the x and the number part, we're almost done, but we have not yet isolated y. So I'm going to isolate y by dividing every single thing by that negative 3. Negative divided by a negative is a positive, and minus 2/3. So all I've done here is rewritten 4x minus 3y equals 2 into slope-intercept form. So it was in standard, and now we have it in slope-intercept. The reason for that is that this clearly tells us what the slope of this line is. If I were to do a rough sketch of this line, its y-intercept is at negative 2/3, so its line probably looks something like that. For this problem, we want the line parallel to that one, but going through this point right here. So as long as we have the same slope and we know the point of the new line, we can write the equation for our new line. Okay, so we have a point of 4, 0, and up here we found our slope to be 4/3. Again, important to make a note of that, circle, highlight it somehow so we know to use it later. So the point is 4, 0, the slope was 4/3, so we can go ahead and transform into point slope form. The problem asked for the line in slope-intercept form, but since we had a point and a slope, it made most sense to start out in point-slope form and then eventually transform to that slope-intercept. So y minus 0 is just y. Let's distribute our 4/3. Oops. There we go. 16/3. And that is the equation of the new line. Lastly, something I would recommend, which we can't really see the step down here, but make sure to graph both lines that are in slope-intercept form in your calculator to make sure they are parallel. So to sum up here, we used the equation of the line we were given solely to help us find the slope. The y-intercept didn't really matter here. The slope is what mattered. Once we found the slope of the line that was given, we had the point of the new line we wanted to write. With that point and slope, we wrote the equation of the line and then just transformed it to the format that was asked. I'll now give you a moment to do the next example problem on your notes and wrap up this video. You can then continue on to the perpendicular lines video.